Hi, today we're going to solve Leetcode 260, single number 3. Given an integer array nums in which exactly two elements appear only once and all the other elements appear exactly twice, find the two elements that appear only once. You can return the answer in any order. You must write an algorithm that runs in linear runtime complexity and uses only constant actor space. Now, anytime you see a problem that says linear runtime complexity and constant space, and it's some kind of find an element that appears once or a couple of times in an array, typically that's indicative that it's some kind of bitwise manipulation type of problem. Now, in order to be able to solve this problem, you should know how to solve 136 single number. The reason for this is that single number 3 is a expansion of 136 single number. Now I'm going to talk about how to solve this really quickly. It's fairly straightforward. In bit manipulation, when you XOR, you're taking and finding all the bits that are different between two binary numbers. So in order to solve 136, I recommend you read through and brush through bit manipulation to make sure you understand it. But basically, you XOR all the numbers with 0, and the number remaining is your answer. And we can see it in the editorial here, where it says bit manipulation. Right, so we XOR all the numbers with 0, and then we return that number. All right, so going back to Leetcode 260, single number, the difference between the previous problem and this problem, we have to identify the exactly two elements which appear once. Okay, well, we know the technique we had before, which was XORing all the numbers. But what does that mean? It means that now when we XOR all the numbers, we end up with a variable that is in the XOR of the two numbers that appear only once, right? So let's take, for example, the different numbers in this array, right? We have 1, 2, 1, 3, 2, 5, right? Okay. Well, what are the different binary numbers here? Okay, so 1 is 0, 0, 1. 2 is 0, 1, 0. And we can just write the rest of these out, right? Whoops. Okay, so looking at this, we can tell right away, we know the answers we're looking for are 3 and 5, right? Because 3 and 5 appear only once in this entire array. So these are duplicated numbers. Okay, so what are we going to get when we XOR all these numbers and then we end up with only 3 and 5, right? So if we get 6. Why do we get 6? Okay, well, let's do this really quick. We start out with 0. We XOR 0, 0, 1, which is 1, and that gives us 1. Got this one. 0, 1, 2, which is 2, and that gives us 0, 1, 1. And you understand that why, right? Because we have the number here, which is different, right? And 0 and 1, those are both different, right? Okay, and then we XOR 0, 0, 1, which is 1. And from there, we get just 1, 0, sorry, 0, 1, 0. Okay. We XOR 0, 1, 1. Now we only get okay. Then we XOR 0, 1, 0. And then finally, we XOR so from XORing, we're going to XOR 0, 0, 0. And that's going to give us 0, 0, 1. Then we XOR 0, 0, 1. And that equals to 1, 0, 1, 1. XOR 0, 1, 1. And that gives us 6. Great. So now, and well, now that we have the number 6, this represents the XOR of both 3 and 5, right? And we can also arrive at that ourselves if we just look at let's take the numbers 3 and 5, right? So 3 is 0, 1, 1. 5 is 0, sorry, 1, 0, 1. If you XOR both of these, what do we get? We get 1, 1, 0. See, the same as what we had earlier, right? So how do we solve this? Well, if only there was some way we were able to figure out one of these numbers, then we would be able to just remove this number from what we can do is we can actually separate this array into 2 groups. All right. And 2 groups can be one group that contains one of the numbers that's different, and the other group can contain numbers that is also different. So one of the groups would contain the 3, and the other groups would contain the 5. How could we do this? Well, let's think. What do we know about these 2 numbers that we have here? We can see that at 2 of the different bits, they're different. Okay, so what if we just grouped all the numbers based off of whether or not they had a bit for that position? So, for example, we could essentially break this problem up into, can we find group 1, can we find all the numbers that have a bit that intersects with 0, 1, 0? And then group 2 could just be the rest. Okay, well, why 0, 1, 0? Actually, we don't have to use 0, 1, 0, right? Because remember what I said earlier, we're just looking for the difference in one of the bits places. So we could actually use, instead of 0, 1, 0, we could use 1, 0, 0. Why? Well, let's take a look. What do we have here? They're both different. So that's why 1, 0, 0 and 1, 0, excuse me, 1, 0, 0 or 0, 1, 0 both would work. Okay, so let's say we're going to group all these by this. What are we going to get? All right, well, let's mark down which one goes into group 1. And I'm gonna circle them here with a green circle. So let's take it the first number, 1, which is, sorry, this should be 1 should be 0 here. All right, let's take a look. Does this number end up in there? Well, if we look at the leftmost bit, it's a 0, right? So that means it goes in a group 2. All right, the next number, 0, 1, 0. Same thing here, right? So we put it in group 2. All right. Again, same thing. 0, 0, 1. What about the 3? Same thing here. So we can actually just really quickly go along and say the rest of these all end up in this group, right? And now we know that here we have our number. Okay, well, the first thing you might be saying, it's kind of obvious what it is, right? Yeah, because we picked the leftmost bit. It's super obvious. But let me give you another counterexample to show why you can use both numbers and it would either bit and it would still work. So let's take this example, right? That's the other possible bit we could use. Let's do it again. All right. Now we're looking for the middle bit that's going to be the same, right? We'll go a little faster because I think you're getting the point of what we're trying to do. In the middle bit, 2 actually goes here, right? Because it's the same this place here as what we're matching for. Aha! Are you seeing something now? All right. We have 2 groups where all the numbers are duplicated except for 1. I bet you're seeing it now. That means we can go ahead and use our previous technique of finding the single number that's different. And then all we have to do is, once we figured out that number that's different, in this case, in the left one, group 1, it's 3. Whoops. We can just go ahead and obviously put that 3 in our results. How do we get the number for this one? Well, remember what XOR does, right? We know that 110, which is 6, represents the XOR of 3 and 5. What if we take this number here and we XOR it with this number? What do we get? Let's do it. Let's figure it out. So we're going to do XOR of 3, which is 0, 1, 1, XOR 1, 1, 0. And we get 1, 0, 1. Hang on, what does this look like? Well, right here, you can see it's 5. So now the question is, how do we actually solve this problem? All right. So we know that we need to, if you remember from earlier, we need to XOR we need to first get to a number that is the XOR of 3 and 5, right? So let's write that code. Great. So then we know now XOR is equal to 110, right? Or 6. Now, let's figure out the difference, right? Because now we have to figure out, what's the first bit that's different? There's actually a number of ways to do it. In the Leetcode editorial, they talk about using x and minus x. And there's a very complicated math reason for why this will give you the binary number that is different, that it's similar to the technique that I talked about earlier, but I'm personally not a fan of it because it's, at least for this problem, it's not really intuitive, right? So, well, why don't we just shift the bits until we find something that's the same? All right, so we know from the problem that it's going to appear in 32 bits, right? So range 32. Okay. Why don't we just shift the bits, right? Let's call this diff. All right. So we know that 1 is equal to 001, right? In binary. Is there some way in which we can go from 001, 010, 100? Yeah, it's called left shifting. So this is how it's going to work. So we check if the difference and the XOR. So what does this AND do? All right. This AND means that we're checking to see if the bits are the same. So in the first iteration of this loop, we're essentially checking, okay, well, this is the first iteration of the loop, right? Call it for iteration number. And we're basically saying, okay, well, the number, the XOR number we're checking is going to be 110. We're checking to see, okay, and is 0, 0, 1. Are these the same? What do we get? We get nothing, right? Because this here, these aren't the same, right? So it's not going to work. So we're going to break if it doesn't match, right? And then what we want to do is we want to shift the diff over, right? So we do left shift, and this is how you do it. 2 left arrows and a 1. Okay. Well, first one didn't look. First iteration of the loop didn't work, right? What about the second one? So we're going to shift it 1, so that means it's going to be 0, 1, 0. And then let's run it now. Okay. Oh, hey, look. We have a match. These numbers are the same. Awesome. So then we break there. All right. And then now what do we have to do? Now that we have this number, which represents, remember this, the 0, 1, 0. Well, we have to group it, right? How do we do that? So let's say group. We go through every number in the nums. Similar concept, right? We have the and. So if num and group, if it matches, then we want to do, sorry, this is not group. This is going to be diff. Group. We're going to put it in a group, right? And this is just same as doing, all right, it's just a shorthand of it. Num. Okay. So now, what does this get us? Group is equal to what we have in group 1, right? All these numbers are here. And then all we have to do it's not equal to all the numbers in here. We have, what it means is that we have, it's going to equal to the 3 here, right? Because this is the same technique we talked about earlier, which was it finds you that number that's different. So then we have our results. We can put the first number in there, and then we add, how do we find the other number now that we have 3? Well, remember, once we have the 110, we just have to XOR it to get the other number, right? So then that's the math we did down here. And then we just have to do XOR group. And that's it. That is the answer. Boom. All right. Well, thanks a lot. Appreciate you tuning into this, and hopefully there'll be more videos like this.